This is the notes for sketching radical functions. I'm just going to show you a little bit about square and cube roots so that the next time we meet, we can go into further detail. What I would like to do is I would like to talk about the basic square root, which is called the parent graph. So m of x equals the square root of x. And since you've never graphed this, I'm going to go ahead and I'm going to do a table just so you get an idea what this looks like. So what kind of numbers can I plug in for x? Well, I could plug in a 0, and if I plug in a 0, the square root of 0 is 0. So I have a point at 0, 0. I can plug in a 1, and if I plug in a 1, the square root of 1 is 1, so I have a point at 1, 1. If I plug in a 2, I have the square root of 2. That's not very pretty to take the square root of. Instead of taking this, plugging in a 2, maybe I should plug in a different number. You don't have to. I'm just trying to show you alternatives. I can take the square root of 4. So if I plug in this 4, I get 2. So write 4 up 2. Now, if I were to plug in a negative 1, I get the square root of negative, I can't take the square root of negative 1. So, unfortunately, I can't take the square root of negative numbers. So notice that the numbers I was allowed to plug in was the number 0 and numbers bigger than 0. So I started here at the blue dot, and I'm going up towards the right. This is called a radical function, a square root function, actually, to be more specific. I started at 0, 0 because there was no number inside the square root and no number outside the square root. My vertical stretch is always that number in front, and there was no number in front of the radical. Do you notice how, though, I would go up 1, right 1? So from my starting point, I went up 1, right 1. And my domain, so notice domain, that is referring to all the x values that I can plug in. So what x values can I plug in? I'm only allowed to plug in numbers that start with 0 and then were bigger than 0. So x was allowed to equal 0 and x was allowed to be bigger than 0. So x is greater than or equal to 0. I want to go a little bit more in depth here about this. So again, it's just basic square root functions. I would like to graph f of x equals 2 times the square root of x minus 3 plus 4. So the first thing I want to notice is that this is a square root function. And I always want to start the opposite of the inside. So the opposite of negative 3 is positive 3. And I keep the outside number, which is 4. Right 3, up 4. Then I look at my vertical stretch. That is the number in front of the square root function. So the number in front of the square root function, this right here is what we call a. That's the vertical stretch. That's 2 over 1. So from our starting point, I go up 2, right 1. And those are the only 2 points you need. You could plug in more points and you could see more points that are on this radical function or this square root function, but we only need to plug in a couple just to get an idea what this looks like. So since it starts at 3, 4, and it goes up towards that purple dot, I'm going to start at the blue one and go up towards the right. So again, domain is referring to all the x values I'm allowed to plug in. It is always x equals h. So x equals 3, but in this case, it's going to be greater than or equal to 3 because it starts at 3. I'm allowed to plug in 3. I'm allowed to plug in 4. I'm allowed to plug in 5. But I couldn't plug in, for example, 2 because if I were to plug in 2, the square root would be of -1. You can't do that. So let's take a look at the next one right here. Ooh, now notice it's I of x equals -3 times the square root of x plus 2. I wonder what that -3 means to do. So this is a square root function, so I always know that my starting point is the opposite of the inside, and I keep the outside. So I'm starting at -2, 0. My vertical stretch is that number in front of the absolute value. So my vertical stretch is -3/1. So instead of going up 3, I'm going down 3. And make sure you realize that's +1. So down 1, 2, 3, right 1. So instead of going up to the right, it is going down to the right. Remember my saying that I always have, sorry, left-handers, but right-handers rule. When your right arm goes up, it starts with the positive, and when your right arm goes down, it starts with the negative. Now, how does that affect the domain? Okay. Well, again, it's always x equals h. H is that first number and the starting point. So x equals -2. But what other numbers am I allowed to plug in? Am I allowed to plug in -3? Or am I allowed to plug in +3? Well, if I plug in -3, you see how it would cause the square root to be -1. So it could only be positive numbers. So it has to be x is greater than or equal to -2. We're going to be talking a little bit more about domain the next time I see you as well. So that is called the basic square root function. So now I want to look at the basic cubed root function. Okay. So again, I haven't graphed this before, so I'm going to go ahead and just plug in some numbers to get an idea what this looks like. So I want to plug in 0 because 0 is an easy number to plug in. And when I have the cubed root of 0, what 3 numbers that are exactly the same that multiply to 0? I get 0. And I can plug in a 1 because I can take the cubed root of 1. I'm trying to plug in numbers that I can take cubed roots easily of. Cubed root of 1 is 1, so I will point out 1, 1. And I can plug in a, nah, I don't really want to plug in a 2 because cubed root of 2 is not so nice. Let me see, 3, no, 4, no, 5, no, 6, no. I know I can plug in an 8 because I can take the cubed root of 8. The cubed root of 8 is 2. Not that you can't take the cubed root of the other numbers. I just don't have a calculator on me at the moment. So I'm going to go write 8 up 2. Now, am I only allowed to plug in positive numbers or could I plug in negative numbers? So let's just plug in some negative numbers. Could I plug in -1? Are there 3 numbers exactly the same that multiply to -1? Yes. If I plug in -1, I get -1. Could I plug in other numbers besides -1? Like, could I plug in -8? Because again, I'm looking for numbers I can take cubed roots of. If I take the cubed root of -8, I get -2. So I have a point at -8, -2. And this right here is your basic, or what we call our parent graph of a cube root function. It kind of looks like this stretched out S, okay? And so our starting point is just like our square root functions. It's always the opposite of the inside. Keep the outside, but there is no number inside and no number outside. So in this case, it's 0, 0. And just like the square root functions, our vertical stretch is always that number in front of the radical, which in this case, in front of the cubed root is a 1. So notice I can go up 1, right 1, but I also went down 1, left 1. Now, there isn't just 3 dots on here. There's 5 dots on here. So the vertical stretch helps you find your second and your third dot. So our second dot was up 1, right 1. Our third dot was down 1, right 1. But how do I go to the fourth and fifth dot? Well, notice from the second to the fourth dot, I had to go up 1, right? 1, 2, 3, 4, 5, 6, 7. It always has that pattern. Or I guess you can say it's like going up 2, right 8. Okay. So it depends on how you look at it. So from the starting point. So this is our fourth and our fifth point. We go up 8. Oops. Sorry. Up 2, right 8, and down 2, left 8. So again, from our starting point, up 2, right 8, down 2, left 8. Now our domain, what values of x were I allowed to plug in? Was there any restrictions? Well, I was able to plug in positives. I was able to plug in 0, and I was able to plug in negatives. I was able to plug in any single number. And because I was able to plug in every single number, there was no restriction. So our domain is what we call all real numbers. And we use this capital R. It's a little fancy to represent all real numbers, so you don't have to write it all the time. So let's take a look at this next cube root function, g of x equals the cubed root of x plus 2. So I know it's going to be this stretched out S shape because it's a cubed root. I always do the opposite of the inside, keep the outside for where I'm starting. Well, there's no number inside, so it's 0, and the outside number is 2. My vertical stretch, which is the number in front of this, is -1. And so -1 over 1 means that you're going to go down 1, right 1, and up 1, left 1. Now, this right here is for our second and our third point. But remember, I have a fourth and fifth point. And so the rule is that you always take, okay, you always take, because this is now the fourth and fifth points, it's like the second layer, is it's always 2 over 8. Because the second point I went down to, right 8, the fourth point I have to go down to, right 8. And the fourth point, I'm going up to left 8. So from the starting point, which is 0, 2, I'm going to go down to 1, 2, right 1, 2, 3, 4, 5, 6, 7, 8. and then go back to the starting point. I'm going to go the opposite direction, up 2, left 1, 2, 3, 4, 5, 6, 7, 8. And the domain for cubed root functions is always all real numbers because there's not any restrictions on what I can plug in for x and what I can plug in for y. Now notice that right arm is going down to the right because it starts with a negative versus the previous problem where the right arm goes up to the right because it started with a positive. So one more, again, we're just trying to get that basic idea so that we could, one, complete our homework, but two, kind of hit the ground running next time we see each other. Where is our starting point on this one? That's g of x equals 2 times the cube root of x plus 1 minus 3. It is always the opposite of the inside, which in this case will be negative 1. Keep the outside, which is negative 3. So left 1, down 3. Our starting point, not our starting point, our vertical stretch is 2. So this is 2 over 1. So that means you're going to go up to right 1 and down to left 1. But how does that affect point, so for point 4 and 5? So you always take your A and you multiply that by 2 over 8. So since our A is 2, 2 times 2 over 8, that is going to be 4 over 8. So you're going to go up 4, right 8, and down 4, left 8. And then again, this is from our starting point. We were starting at negative 1, negative 3. So from that blue dot, I'm going to go up 1, 2, 3, 4, right 1, 2, 3, 4, 5, 6, 7, 8. And then down 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. I know it's a little bit of a challenge. Again, we're just trying to get an introduction so we can kind of hit the ground running a little bit more. So the domain is always all real numbers when we're talking about cubic functions because, again, you can plug in any number, positives, negatives, and so on. Now, that was kind of an introduction because technically your homework is going backwards. In some ways, it's a little bit easier. You're given choices and you're trying to look at that maze to see which choice matches up with the graph. So when it comes to square root functions, all you want to do is kind of ask yourself, where do they start and how do I get to the next point? So again, that's the first thing. Where do you start? And then what's the next point? Or how do you get to the next point? So on a square root function, it's always y equals or f of x equals or g of x equals. And I'm going to go ahead and draw my square root functions with the x inside of it. I always look where I start, which in the very first one on the top left, it's starting at positive 3 comma 6. So I do the opposite of the first one, and I keep the second one. So the opposite of 3 is negative 3, and I keep the 6. So if I take a look at the one on the right, I'm starting here at -1, 0. So again, if I do the opposite of the first one and I keep the second one, the opposite of -1 is +1, and the number outside is 0. I'm trying to find, how do I get to the next point? So it's always something over 1. So it looks like I go up 1, right 1. So here, A is 1 over 1, which is 1 on the top left. And this next one, I have to go down 1, 2, 3, right 1. I'm going down 3, right 1, so it's -3. So your homework is just trying to look at the maze and then kind of ask yourself, here's a graph. What part of the maze, having the choices, which one does it match to so you can get through the maze? The last two are what we call cubic functions. That stretched out S, right? Cubic functions or cubic roots. So y equals f of x equals g of x equals a of x equals. Just make sure that you have a cubed root with an x in it. Just like the other ones, we're looking for where do we start, right? And we always determine where do we start when we look in the middle of the S, right? Where the curves change. And just like the square root functions is, how do we get to the next points? So I'm looking for, if I were to follow the left of this curve and I would follow all the way down, notice it kind of changes right here before it goes down to the right. It kind of changes right here. Okay. So this right here is at 2, 0. So if I do the opposite of the inside, I get -2. And if I keep the outside, I get 0. So again, follow the curve. If I were to follow the curve, looking for where it changes before it goes the other direction, it kind of changes right here. Oh, wait a minute. I have this graph written down twice. That was by accident. Oops. Sometimes that happens. I guess I don't have to do this problem. Okay. So now, how do I get from the first point at 2, 0 to the next point? So I want to look to see, how do I get there? So it's always something over 1. So if I look at it, it's like here. Oops. It's not drawing very well. Looks like I have to go up 1, left 1, and down 1, right 1. So down 1, right 1, and up 1, left 1. Looks like A is -1 over 1, which is -1. Please come in for tutoring if you need absolutely any extra help. Have a great day.